All right, we're going to do section 9.3, page 461, number 31, which reads, show that the three functions grow at the same rate as x goes to infinity. And my three functions are f1 of x is the square root of x, f2 is the square root of 10x plus 1, and f3 is the square root of x plus 1. Now, the only tools that I have to examine how functions grow compares two functions at a time. But if I can show that f1 and f2 grow at the same rate, and f1 and f3 grow at the same rate, then I can use transitivity to show that f2 and f3 must therefore grow at the same rate. So I'm going to compare these functions in pairs, and I need to show that that limit as x goes to infinity is going to be equal to a non-zero constant for both pairs of functions. Doesn't necessarily have to be the same constant. So I'm going to start with the limit as x goes to infinity, and I'm going to start by comparing f2 of x and f1 of x. Now, it doesn't matter which pairs you take, but you want to try to make the algebra easy for yourself, and you're going to see that this is going to help us here. So I've got the limit as x goes to infinity of the square root of 10x plus 1 over the square root of x. And I'm going to start by putting everything under the same radical. So I'm going to have the limit, oops, let's see if we can undo that. I'm going to have the limit as x goes to infinity of the square root of 10x plus 1 over x. And then I'm going to break this up into two fractions. So I'm going to have the limit as x goes to infinity of the square root of 10, because x over x is going to cancel and give me 1, plus 1 over x. And then when I substitute in infinity for this limit, I'm going to get the square root of 10 plus 1 over infinity, or the square root of 10 plus 0, which is just going to give me the square root of 10. And that is a non-zero constant, and that tells me that f1 and f2 are going to grow at the same rate. So now I'm going to take a different pair of functions and show that they grow at the same rate. So I'm going to take my limit as x goes to infinity, and this time I'm going to compare f3 of x to f1 of x. So I'm going to have the limit as x goes to infinity, and I'm going to have the square root of x plus 1 over the square root of x. And again, I want to put this all under one radical sign, so I'm going to have the limit as x goes to infinity of the square root of x plus 1 over x. And again, I want to turn this into the sum of two fractions, so I'm going to have the limit as x goes to infinity of the square root of x over x, which is going to give me 1, plus 1 over x. And now when I substitute in infinity for x, I'm going to end up with 1 plus 1 over infinity, or 1 plus 0 under that square root sign. So I'm really just going to have the square root of 1, which is 1. So now I can say that f1 and f3 grow at the same rate. I've already shown that f1 and f2 grow at the same rate. And transitivity tells me that if I have two functions that grow at the same rate, and one of those functions grows at the same rate as a third function, then f2 and f3 must also grow at the same rate. So this is telling me that all three functions grow at the same rate as x goes to infinity.